The chapter we've been waiting all year for, circles. The first lesson is using properties of a tangent to a circle. Questions. What measure is needed to find the circumference or the area of the circle? To find the circumference or the area of a circle, you need a radius or a diameter. If they give you a radius, twice the radius is the diameter. If they give the diameter, half the diameter is the radius. Find the radius of a circle with a diameter of 8 centimeters. That's 4 centimeters. A right triangle has legs with lengths of 5 inches and 12 inches. Find the length of the hypotenuse. So c squared equals a squared, we're going to call that 25, plus b squared, 144. 144 plus 25 is 169, and the square root of 169 is 13. Next one, solve 6x plus 15 equals 33. I subtract 15 from both sides. I know you're laughing at me. I should be able to do this without a calculator, and I'm sure I can. But 33 minus 15 is, of course, 18. That's why you're laughing at me at home. So x equals 3. So let's work this out. X plus 18 times x plus 18 is x squared. 18x plus 18x is 36. Double checking that because it's Sunday and I'm not thinking. And 18 squared is 324. And that's 36x there. Equals x squared, 24, times 24 is 576. If I subtract x squared from both sides, I get 36x plus 324 equals 576. 576 minus 324 is 252, and 252 divided by 36 is 7. A circle is a set of all points in a plane that are equidistant from a given point, which is called the center of the circle. A circle with center P is called circle P, and it can be written as a circle with a dot in the middle, P. A segment whose endpoints are the center, and any point on the circle is the radius. You know that. A chord is a segment whose endpoints are on a circle. A diameter is a special chord that goes through the center of the circle. You're familiar with radius and diameter. A secant is a line that intersects a circle in 2 points. So if it's a segment here, just highlight that, that's a chord. But if they draw it on with arrows and make it a line, it's a secant when it goes through 2 points. A tangent is a line in a plane of a circle that intersects the circle in exactly 1 point, called the point of tangency. A tangent ray, AB, and the tangent segment, AB, are also called tangents. We're now going to use what we've just learned to just be able to identify vocabulary. So if I look at A, segment AC, that's a radius. AB is a diameter. Ray, DE, is a tangent ray because it is contained in a line that intersects the circle at only one point, at this point, point B. Line AE is a secant because it is a line that intersects the circle at 2 points. So in example 1, what word best describes AG and also CB? So AG is a chord because we're just talking about the segment. CB is a radius. Let's see if I'm right. AG is a chord, woohoo, and CB is a radius. And in example 1, name a tangent and a tangent segment. So DB would be a tangent segment, BE would be a tangent segment, the tangent would be line DE. Okay, so we said DB, but you could also use BE as your tangent segment. You could even use D to E, just this segment as your tangent segment. You would then just need to write this, the difference between segment and that meaning line. The word radius and diameter are used for lengths as well as segments. For a given circle, think of a radius and a diameter as segments and the radius and the diameter as lengths. So, okay, so find the given lengths. The radius of circle A is 3 units. The diameter of circle A is 6 units. The radius of B is 2 units. The diameter is 4 units. The radius of circle C would also be 3 units. Diameter of C would be 6 units. The radius of circle D would be 2 units, and the diameter is 4 units. I see that in this problem they only asked for A and B, but we can do that. Oh, they just asked us to find C and D. They kind of went ahead of you. Here they are. Coplanar circles. 2 circles can intersect in 2 points, 1 point, or no points. Remember, coplanar means they're in the same plane. If they intersect at only 1 point, they're called tangent circles. If they have two common points, that's the example. So 1 common point is a tangent, and no common points is called concentric. A line, ray, or segment that is tangent to 2 coplanar circles is called a common tangent. So even though these have no points of intersection, they have a common tangent. These have a common tangent here. They also could have, I think this is going to show this to you shortly, a common tangent there. They could also have a common tangent like that, or they could have a common tangent like that. Same thing here. These can have a common tangent. Oh, they're the same circles, sets of circles. Common tangent there. So these 2 circles can have 4 common tangents. And now they ask us to draw common tangents, which I kind of just did, the 4 common tangents. This one would have a common tangent there, 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 okay, and see, show there are 2 common tangents there, across there, and there. None in the middle, because then they would intersect, the tangents would intersect in more than 1 point. And tell how many common tangents these circles have and draw them. Kind of just did that example, so I'll just pull that away. It's 2 common tangents, and that would be how they are drawn. Tell how many common tangents these circles have and draw them. It's just going to be 1 common tangent. Draw it like along there, And that's what I drew. Well, that's what I tried to draw. I must have moved this away when I was talking. There we go. That's how it should look. Don't want to mess you up there. How many common tangents do these circles have? They're concentric. One is inside the other, and they have no common tangents. So now we're going to get into a theorem. In a plane, a line is tangent to a circle if and only if the line is perpendicular to the radius. So no matter where I draw a tangent here, so for instance, get my straight line tool, let me draw a tangent there. I could obviously make a line from here. I could construct a perpendicular line, perpendicular segment from here to that center of that circle that's shown there. And when I create a line segment from the center of a circle to the point of tangency, that radius, it's always going to intersect that tangent. I can always do that at 90 degrees. When I have a 90-degree angle, it makes it useful because, of course, I can start using Pythagorean Theorem. In this diagram, they tell me that PT is a radius and ST is tangent. So that means that's a 90-degree angle. Okay? So I'm using the Pythagorean Theorem, sorry, to show that that's a 90-degree angle. In this case, 12 squared plus 35 squared is equal to 37 squared, so this is a right triangle. Okay, here's a new problem. In this diagram, B is a point of tangency. Find the radius of C. So this would be a radius, this would be a radius, meaning this here must be a 90-degree angle. So my radius plus 50 squared, because 50 plus r plus 50 is my hypotenuse. I square that. That's going to be equal to a squared, which we're going to call the radius, r squared, plus 80 squared. If you see this, actually, this equation here now looks like what we had to solve in the warm-up. So r squared plus 100r plus 2500, when I FOIL that out, equals r squared plus 6400. Subtract r squared from both sides. Subtract 2500 from both sides. You get 100r equals 3900. So the radius is 39 feet. Theorem 10.2. Tangent segments from a common external point are congruent. So since r is a point of tangency and t is a point of tangency, rs is going to be congruent to ts. Here's an example of how we could use that. RS is a tangent to circle C, tangent segment, and RT is a tangent segment to circle C. They both have point R in common, so find the value of x. So 3x plus 4 is going to equal 28. When we solve, subtract 4 from both sides. So 28 minus 4 is 24. 24 equals 3x. I divide both sides by 3, and I get 8 equals x. And let's try this here. Is DE tangent to circle C? So this is actually from example 4. So the question is that a 90-degree angle? Okay, this, what they're saying here, I know this is misleading. This part here is 2, so this is 3. So one side is 3 squared, one leg, plus 4 squared equals 5 squared. Now you might recognize 3, 4, and 5 is a Pythagorean triple, but if you didn't, 5 squared is 25, 3 squared is 9, 4 squared is 16, 9 plus 16 is 25. That's correct. So this is a right angle, so it is tangent. ST is tangent to Q. Find the value of R. So the hypotenuse is the r plus 18. That's the hypotenuse. So r plus 18 squared is going to equal r squared plus 24 squared. So when I FOIL this, I think this is actually the exact problem we had in the warm-up. R squared plus 18r, and 18r is 36r, plus I don't remember what 18 squared is. Maybe you do. Maybe you have your warm-up still out. 18 squared is 324. I think 24 squared is 576, but I'm not going to check it, risk it, it is. I subtract r squared from both sides. I get 36r plus 324 equals 576. 576 minus 324 is 252. I divide by 36, and I get r is equal to 7. And find the value of x. X squared is equal to 9, so x is equal to 3. Now, yes, we talk about this all the time, and that should say positive or negative. But I'm going to go with it is only positive 3 because you cannot have a negative distance. So you can't have negative. Give the name that best describes the figure. CD, while it contains the diameter, extends past the circle. It's a secant. AB, as a line, is a tangent. If it was, then it would just be a tangent segment. FD is a chord, and EP is a radius. This circle has one common tangent, and it's a vertical line right there. This will be messed up, but basically right there through the point of tangency. Is AB tangent to circle C? So in that case, that would need to be a 90-degree angle. This would need to be the radius. Oh, this whole thing is 34. So that's pretty easy to check. 16 squared plus 30 squared equals 34 squared. Let's see if that works. 16 squared is 256. 30 squared is 900. 34 squared is 11,156. 900 plus 256 is 11,156. So AB is tangent. Now they want me to find x. So 3x minus 1 has to be equal to 2x plus 11. Because these are both appear to be tangents, and they have common point A. So if I subtract 2x from both sides, I get x minus 1 equals 11. If I add 1 to both sides, x equals 12. And here are the problems from which comes your homework. Hope you enjoyed our first circle lesson.